Hello everyone, today I'll prepare a specific set. This is set 1 of the easy level. This set refers to algebraic expressions, how to simplify, how to work with surds, how to work with indices. It's all about that, and this is for A-level students and also for students of general maths. Alright, so everyone welcome. If you want to recap that, this is right for you. So this level is of easy one because it has deal with just basic simplifications. It's how to work with polynomials basically. It doesn't refer to the questions about how to multiply them, how to divide. So the maximum that you can find how to add or subtract polynomials by providing like terms. And also it's all about indices and exponents, right? So indices and exponents, and also how to rationalize expressions like questions similar to rationalize denominator and this stuff. Okay, it's how to work with surds. All right, so let's start with the question 1. I'll provide several questions in this set, and that's going to be a good revision for you. So grab your pens, grab your notes, and let's get started. So question 1, for the following polynomial that you can see here, you need to find how many terms are there. Alright, so terms, basically each separate thing that you can see here is called term, basically the element. So that's why in polynomial, terms are separated exponents with coefficients which you add or subtract. Okay, so that's why the answer here is 3, because you can see 3 separate elements. Okay, so the last is going to be the free coefficient because it doesn't contain any x value, because x in the power 0, which is 1, right? So that's why it's called free coefficient. So what is the coefficient of the fifth power of x? So here is the fifth power of x, this term, and that's why the coefficient is 7. What is the constant term? So as I said, the constant term means it doesn't contain x value at all. So that's basically a number. But be careful that this term contains the sign before. So always sign before relates to the coefficient. Okay, so that's why it's -8. And that's the constant term. All right, let's get into the next one. Question 2 refers to how to simplify the expressions. So expressions basically in this case contains brackets, it contains exponents, so generally it's basically polynomial expressions. All right, so that's why you need to remember how to work with polynomials. First of all, if you see the brackets, that's of the first preference of the highest preference operation, so that's why you need to expand the brackets. And what we're gonna do, we're gonna use this coefficient as the common factor, and we just distribute it to both terms. All right, so that's why you'll get 3x to the power 7 minus 3x cubed. Here is you have -2 factor, you also distribute it to both terms, so that's why you'll get -2x cubed minus 2x to the power 7 and minus 6. All right, so what to do next? The next step is to find similar terms, which is basically exponents to the power 7 and also another pair or group of terms which contain power 3. Okay, they're similar terms or like terms, the terms which has the same power of the exponent. All right, so that's why we can simplify them. In order to do that, so the actually strategy here, for example, I just show you why it's that so that you understand. What I'm going to do, I'm going to factorize x to the power 7 because of the common factor, and in the brackets we'll get 3 minus 2. Okay, so you subtract, you'll get 1 times x to the power 7 is just x to the power 7. But the strategy here is pretty straightforward. You just don't touch the exponents. Okay, you leave as it is and work with numbers before the exponents. So basically you're working with coefficients. 3 minus 2 is going to be 1, so just 1 times x to the power 7 is just x to the power 7. All right, so next, minus 3x cubed and minus 2x cubed. And finally, you'll get minus 5 x cubed using the same technique, and minus 6. So final expression is just x to the power 7 minus 5x cubed and minus 6. That's going to be the final expression because minus 6 is the free coefficient and you're not eligible to touch that. So just leave as it is. Alright, so let's move to the next one. In question 3, we need to solve quadratic equation. Okay, so hope you remember, it might be picked up. So basically the approaches how to solve quadratic equations you might pick up from GCSE level, right? It's all previous knowledge and it's new knowledge for A level. So if you are not sure how to solve that, just make sure you watch the previous videos related to GCSE. Here is the hint, alright? And we start doing. We need to give the answer in the form a plus square root of b. So where a, b are integers. So here to z or up from z means that they're integers. So a and b integers, and we basically need to give the answer in this surd form basically, okay, because it contains surd here, okay, that's what is called surd. Square root of number that cannot be evaluated up to the whole number, right? So it's a rational number or surd. Okay, so the way we gonna do that, how to solve quadratic equation, I'm gonna use quadratic formula. So make sure you remember what it is, what stands for the term quadratic formula, and I'm going to use that. So according to the quadratic formula, the solution might be written in the form minus b plus minus square root of b squared minus 4ac and everything over 2a. Okay, what stays for a, b, and c? So this is the general form x squared plus bx and plus c equals 0. So this is the standard form of the quadratic equations. So we just need to compare term by term, finding out coefficients. So coefficient a is 1, coefficient b is 4, and coefficient c is negative 3. So we're just gonna plug into this formula in order to find x values. Alright, so let's do this. So minus b is minus 4 plus minus square root of, and we have 16, which is 4 squared, minus 4 times negative 3 is going to be plus 12, and times a, which is 1, so just plus 12, okay? So over 2a, which is just over 2. Okay, so what we're going to do right now, we're just going to take the square root of 16 plus 12 is going to be 28. So let's remember how to work with surds. So square root of 28 is square root of 4 times 7. So that means we can say that it's 2 square root of 7, okay? So 2 square root of 7, and we can write minus 4 plus minus 2 square root of 7 and everything over 2. Alright, so we just do division by parts. It means we divide minus 4 by 2, which has the result of minus 2, and 2 square root of 7 over 2, 2 will be cancelled, so it's going to be just square root of 7, so plus minus square root of 7. So we have two solutions, means x1 is going to be minus 2, let's take plus square root of 7, and x2, that's going to be minus 2 and minus square root of 7. So if we compare what we have originally, the form that we need to provide, a and b should be integers. So let's check. So a in the first case is minus 2, while b is the coefficient before square root of 7, before the square root. So it's going to be just 1, right? It's not 0, pay attention to it. So in the second expression, second solution, a is the same, but b in this case is going to be minus 1. Alright, so that's the solution, and that's the answer to question 3. So make sure you got the same. And let's move to the next one. In this question, you need to solve the following inequality. Let's have a look at the type of inequality. That's definitely linear because all terms containing x are in the first power or have the first power, power 1. So that means it's pretty easy how to solve that. You need to collect similar terms on one side and and now the three coefficients in the other side. In this case, we're collecting all x's on the right side. Why? Because when transfer 2x to the right side, you'll get 7x minus 2x, which is positive 5x. So that's good. Try to stick to the rule that once you collect in the terms, they should have positive coefficients. This is the strategy. In this case, you won't need to invert the sign. So you leave the sign of inequality more equal as it is and write in 7x minus 5x, okay? And minus 8, you transfer to the left side to 6. It's going to be positive 8, and hence you'll get 6 plus 8. Now you simplify that, and you'll get 14 more equal than 7x minus it's 2x, right? Okay, so 2x. Now what we're gonna do, we're going to, what's the problem here? Okay, so we're going to find x by dividing everything by 2. So we've got 7 more equal than x. So, but it's not like good, because in this form, it's better to rewrite using the following way. So I just rewrite and give the answer in the form x less than equal than 7, okay? Now you need to draw your solution on number line. Basically, by the way, let's consider that x is from q. So x is a rational number, but hold on, we've got an integer or even whole number. So just remember that z is from q if you remember a set theory, because all integers can be represented as a rational number. For example, in this case, 7/1, right? So what it means? It means that right now we've got the boundary point as the rational number, and that's good. Okay, so draw your solution on number line. So that for this reason, I'm just going to use straight line. That's going to be number line. Let's set aside here, okay? Sorry, let's lay out here, and number line goes to the right direction. So we've got a boundary point, which you need to fill it up, right? It's fill in point. And solution, everything below or less than 7, including 7 cells. So just you shading this region, okay? So basically the solution goes up to -infinity, okay? And in question 3, or part 3, I mean, of question 4, you need to give the solution using interval notation. So interval notation means that x is from set, right? And now you understand that your set is from -infinity to 7, so you're starting from the smallest possible number is -infinity, up to 7. And now you're thinking about which type of brackets you need to put. So I'm going to use square brackets here because I will include this value, right, boundary value, because of the inequality sign, which also allows you to be equal to 7. So that's why I'm going to use square brackets here, okay, and basically round brackets on the left side, because both signs infinity and -infinity should contain those round brackets. Oh, okay, so I hope you got it. So just in case, for example, for some solution, for some inequality we've got from let's say 2 to 7, for example. This is just another example. I will show you how to use this notation using interval, okay? So right now we have inequality solution. Let it be solution. This is just another example for not to get confused. Another example, okay? We've got solution and we want to give an interval notation, okay? So what it means that we need to put 2, we need to put 7, and we need to combine them, right? Using appropriate brackets, okay? But what if solution is from 2 to 7 and from, let's say, 9 to infinity, okay? So let it be x greater or equal than 9. How to combine those two intervals? You just need to use union sign, like just the letter U. So in combination with 9 to positive infinity in this case. So that's how it look like if you have like several solutions, so like several intervals as a solution. So how to combine them using union. So that means union sign. Okay, hope you got it. Let's move to the next question. Question 5 refers to basically how to work with exponents in combination with surds, because you see somewhere you will observe square root, you have observed cube root of expression which is squared, okay, and so on. How to work so that the final polynomial should be represented in exponential form for each term. So each term of the polynomial should have an exponent form, so x to some power. How to do that? You just need to convert all square roots, all roots of different powers into the exponents, all right? And just remember how we work with indices. So this basically referred to their topic, which is called indices or index form, how to work with that. All right, so what are we gonna do? I'm just gonna continue here. First of all, I'll convert each roots in the powers. So x squared, so that means we have minus x. The power stays in the top while the bottom takes the power of the root, okay? So the power of the root, in this case 3, goes always in the bottom part, okay? That's how we convert into the exponents. So x, however, the power is not really stated here. Square root means a root of power 2, so that means we have in the power 1 over 2. And we add x to the power 1 over 4. Okay, so what we're going to do right now, we just need to expand the brackets. So I'll take the first term, for example, x squared, and multiply by the first and by the second one, okay? So this is how it works. During multiplication, you add in the powers. So 2 plus 1 over 2 is going to be 2.5, okay? 2.5. Next one, x squared times x1 over 4, it's going to be plus x to the power 2.25, okay? Then you go next, and you distributed negative x to the power 2 over 3 by each term. So you multiply by each term. So that's why it's going to be 2 over 3 and plus 1 over 2, okay? You'll get, right now I'm just writing 2 over 3 plus 1 over 2. And the last term, which is minus x to the power 2 over 3 and plus 1 over 4, okay? You're just adding indices, all right, all powers. So I'll continue here, and let's see what we got. I just want, so you can leave as it is because you're not really stated what exponential power should look like, but just if you want, I can show you how to convert into improper fractions. So 2 times 2 is 4, plus 1 is going to be 5. So as improper fraction, we've got 5 over 2. So next one, the same, is going to be 8, and plus 1 is going to be 9. So 9 over 4. And here we need to add the powers. So how to add two fractions? Let's remember how it works. You just go to the common denominator and use the crisscross. So 3. Okay, it's too small. Okay, 3 goes here and 2 goes in crisscross way here. Okay, it's going to be 4 plus 3. You get 4 plus 3, you get 7 over 6. Okay, that's going to be solution. I mean, not solution, but interim operation. So it's going to be 7 over 6. Okay, and the last power is 2 over 3 and 1 over 4. You do the same. So you multiply in denominators and goes in cross way as the common factors, okay? So it's going to be 8 plus 3 is going to be 11. So finally it's going to be 11 over 12. So this is the way how it works. So I subtract 11 over 12. And let's have a look. Everything meets the requirements. So each term is written in the exponential form. If you need finally to convert back, for example, into the third form, there is no problem. For example, I'll just show you how to do that. So this is solution right now. And I just, for simplicity, if you have another assignment, for example, you need to perform every single term in the third form. So how to convert back, basically using the roots. The bottom part tells you the power of the root, so it's going to be square root of x to the power of 5. But you know that this expression can be even more simplified because you can represent as x to the power 4 times x. So you can simplify and you'll get x squared, square root of x. Okay. So if you want, you can perform this form or give this form, or you can stay with the original form. Okay. So, and you can convert term by term in the same way. Okay. So hope you got it. Hope you got it. That was everything referred to indices and everything referred to, you know, how to work with exponents, how to maybe approach quadratic equations just a little bit, but basically they were about surds again. And here is the final question about simplifying rationalizing denominator. Okay, let's have a look. Oops. So this question, actually, we need to do the following. We need to rationalize denominator. What it means that instead of square root of 3, we need to have some integer, all right? How the process works. So we need to multiply both parts by the conjugated expression. So you're looking at the denominator and you'll get this. So conjugate means you need to consider the same structure except for the opposite sign. There were minus, now you multiplying by the expression that contains plus. So in other words, both parts you multiplying by conjugated expression so that your fraction is not going to be changed. So that's why you consider 3 plus 2 square root of 3, okay? And the top one, you also multiplying by the same conjugated expression, so 3 plus 2 square root of 3. Let's see the net effect. You can cancel completely 3 plus 2 square root of 3 in both parts, right? In the top and in the bottom part, so that your fraction is unchanged. So that's the rule, okay? Now, what are you gonna do? How it works? So you just remember the formula of the difference of two squares that works in this way. So if you convert into exponents, you'll get a squared minus b squared. So that means here in the bottom part, it works the same. It's going to be 3 squared minus 2 square root of 3 everything squared. Okay? And if you start expanding those squares, you'll get 9 minus 4, and square root of 3, basically, when squared, you get rid of that. So that means it's going to be 4 times 3. So 4 times 3 is going to be negative 9 minus negative 12 is going to be negative 3. So that's why in the bottom part, you just have negative 3 as the net result. So what about the top part? So the top part need to be expanded as normal brackets, because there is no formula, right? Okay, so 2 times 3 is going to be 6. 2 times 2 is going to be 4 square root of 3. 4 square root of 3. Then minus 3 square root of 2 times 3 is going to be minus 9 square root of 2. And the last one is going to be negative 6 square root of 6. Okay. And actually that's it, because right now you make your denominator rational number. Now it's just integer, it's negative integer, so that means it's okay, you don't have any rationalities here. All right, so if you like, it's your round test, or basically if you're given an assignment, so you need to basically divide everything by -3 if you're asked to perform or state the final expression, so that it has like the form a plus b squared root of 3 plus c squared root of 2 and maybe plus d squared root of 6. So in this case you just divided everything by parts by -3 and you'll get this structure. Alright, so that was 6 questions in this set. I consider as the easy level because that's definitely maybe hard for GCSE program, but it's definitely easier for A-level students. Alright, so I hope you like that. Don't forget to subscribe if you're new watcher here. So smash this like button, and to be notified also smash the bell. Alright, that was Daniel Dallas, and see you next time.